Good morning, dear students. Myself, Dr. Priya. I am working as Associate Professor in Chemistry, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. So, in the previous class, we discussed about Unit 4 energy sources of course Engineering Chemistry that include introduction to fuels, their definition and their classification, and then a calorific value and how it can be measured, units of calorific value and how it can be determined using different ways. In that Dulong's formula, using Dulong's formula, we determine the calorific value of a supplied sample, and then some problematic part related to that topic, that is Dulong's formula, and then also discussed about characteristics of a good fuel. What are the satisfactory requirements of a good fuel? So far, we discussed about all these topics. In today's session, we are going to discuss about introduction to crude oil. It is also known as petroleum. Crude oil, we will also call it as petroleum. It is a naturally occurring liquid fuel which comes under liquid fuels, and its chemical composition and classification of crude oil, or we will call it as petroleum, and then how it can be refined. After extraction of crude oil, how it is subjected to refining, that is its purification. So, in today's lecture, we are going to discuss all these topics. Let us start with crude oil or petroleum introduction. So, crude oil or petroleum, that petroleum, it is a Greek word in which petro means rock, oleum means oil. So, that means it is considered to be the rock oil. That means it is produced due to fossilized matter in the earth's crust. That is why it is having another name, that is called rock oil, or simply we will call it as crude oil. So, actually this crude oil, it is dark greenish brown viscous oil that is found in the earth's crust. So, if you consider different layers of earth's crust, different layers of earth's core, so last layer will be of brine solution, that is NaCl. If you notice, last layer will be of brine solution. This is earth's core I am going to explain you about. So, last layer, if you come from deep in the earth's core, so last it is having only NaCl, or we will call it as brine solution. It will contain only brine solution. So, upon that we can have this crude oil. Sometimes it is associated with natural gas also. Upon that we can find a layer of crude oil and natural gas. Sometimes these two were associated together and sometimes individually they were present. Upon that we will have coal mines, a layer of coal mines. Upon that mineral deposits, various ores of mineral deposits that were produced in the earth's crust, that layer will be present. And upon that we will have rocky components, all rocky components, and sometimes it will have water resources also. Water resources also. So, rocky components along with that water resources will be present. So, and the next layer, it is nothing but what we call it as soil. It is having lot of fertile sediments. So, if you go very deep into the earth's core, it will start with NaCl or brine solution first. Upon that we can have crude oil, or sometimes it is associated with natural gas, or sometimes they will be present individually in different layers. And next to that layer we can find coal mines, and next to that one mineral deposits will be present, and next rocky components, that layer it is made up of, and next one it is nothing but soil, that is surface of the earth, which will have a lot of fertile sediments like nitrogen, phosphorus and potassium. So, now we are going to deal with this crude oil. Okay. So, it is composed of crude oil or petroleum, it is composed of straight chain hydrocarbons. Straight chain hydrocarbons. Hydrocarbons means only they will contain carbon and hydrogen. Those are hydrocarbons. Sometimes very small trace elements will be present. Those are of nitrogen, oxygen and sulfur. So, it is composed of, or its chemical composition generally will have straight chain hydrocarbons, and then cycloparaffins, and then olefins. Olefins are nothing but alkenes which are having double bonds. There is a double bond that is present between two carbons, two or more carbons. We can expect a double bond between different carbon atoms. Those are what we call as alkenes or olefins. So, the cycloparaffins are also known as naphthenes. Cycloparaffins are also known as naphthenes. Okay. So, and then it will have aromatic compounds. So, together with small amounts of nitrogen, oxygen and sulfur. So, if you notice the chemical composition or average composition of a petroleum or crude oil, so it will have a carbon that is having an average percentage of 79.5 to 87.51%, and hydrogen that is of 11.5 to 14.8%, and sulfur it is of 0.1 to 3.5%, and mixture of nitrogen and oxygen, elemental form you need to consider, and it is of a remaining amount that is 0.5. So, among all these things, carbon it is acting like a major component, and the second major component it is hydrogen, and the remaining all are trace amounts. So, there is a permissible limit value for sulfur also during purification made up to permissible limit value. So, let us go with the classification of petroleum. So, crude oil it is classified, or petroleum it is classified into how many types? 3 different types. So, what are they? First one, it is paraffinic base type crude oil. Paraffinic base type crude oil or petroleum. So, it mainly consists of saturated hydrocarbons. Saturated means only single bond presence will be there. Unsaturation means double and triple bonds we can expect. So, hydrocarbons means major only 2 things will be there, carbon and hydrogen, and that number of carbons composition will be from C1 to C35, and a little of naphthalenes, we will call them as cycloparaffins also, and a very trace amount of aromatic compounds. So, and these saturated hydrocarbons, also known as paraffinic hydrocarbons, which will have or which possess a general formula from, that is CnH2n plus 2. So, paraffinic base type crude oil, it is mainly consisting of saturated hydrocarbons, and carbon composition will be from C1 to C35, and trace amounts of naphthalenes, that we will call it as cycloparaffins, and aromatics will be present. So, while refining, these can be removed, and then coming to the general formula of this paraffinic based hydrocarbons or saturated hydrocarbons, it is CnH2n plus 2. So, this is type 1 of crude oil, that is paraffinic base type crude oil. So, let us go with the next one, that is asphaltic base type crude oil. So, asphalt is nothing but a kind of residual content that is obtained during refining of petroleum or crude oil. Residual content that is produced. It is also having a name that is called bitumen. It is also known as bitumen, or in general we will call it as tar. It is used for construction of roads and all. So, that is why it is named to be asphaltic base type crude oil, or it is also named to be bitumen. So, this type of crude oil, it is having a main chemical composition of cycloparaffins, that is naphthenic based, and very small or trace amounts of paraffins and aromatics. So, mainly it is composed of cycloparaffins or naphthalenics or naphthalenic based crude oil. So, and trace amounts of paraffins and aromatics will be present. Third type, it is mixed base type crude oil. Mixed base type crude oil. So, that means it is having a mixture of or a combination of both paraffinic base type and then asphaltic base type hydrocarbons, and very small amounts of semi-solid waxes. So, it is having a mixture of both paraffinic based and asphaltic based hydrocarbons. Along with that, we can expect a trace amount of semi-solid waxes. So, if you notice the paraffinic based type crude oil, as I told you, it will have saturated hydrocarbons. Saturated hydrocarbons it will contain generally. Saturated means we can expect a single bond between 2 carbon atoms. So, and moreover, these are straight chain paraffins or straight chain hydrocarbons. So, this is the example, or we can say general examples for paraffinic based crude oil type. So, and then what is the next type? Second one, it is asphaltic base, or simply we will call them as naphthenic based also. So, coming to this naphthalenic base, that is what we call it as cycloparaffins. These are also known as cycloparaffins. So, that means they do not have any kind of unsaturation, but they possess cyclic structure. That is why they are called cycloparaffins or naphthenic based or asphaltic based crude oil. Examples: derivatives of cyclohexane, This is what we call the structure of cyclohexane, its derivatives, or simply we will call it as a decalin. Now, what is the third type? Mixed base crude oil, or we will call it as aromatic. So, aromatics means, so for any compound that should be called as an example for aromatic compound means it should satisfy some conditions. Among those conditions, first and most important one is it should possess cyclic structure. First condition, it is cyclic structure. It should possess cyclic structure. And second one is it should obey Huckel's rule, that is 4n plus 2 into pi electrons. 4n plus 2 pi electrons. This is what we call it as Huckel's rule. And first thing it should be in cyclic structure, and then it should have delocalization of pi electrons. Delocalization of pi electrons. So, among several satisfactory requirements of aromatic compounds, a minimum these three if they were satisfied. So many are there, but these three are important in today's class. That's why I am stressing on only these 3 points. If these 3 were satisfied, then they will come under aromatic crude oil type, or we will call it as mixed base crude oil type. So, 3 different types of crude oil so far we discussed, and general structures also we discussed. So, let us go with refining, or we can say purification of petroleum or crude oil. Refining is nothing but a kind of purification process of crude oil or petroleum. So, crude oil is separated into various useful fractions by subjecting to fractional distillation, and finally it is converted to desired specific products or desired specific fractions like petrol, diesel, kerosene, and then naphtha, heavy oil, like that, and finally we will get CNG, that is compressed natural gas. All these things we will get as fractions from this refining of crude oil or petroleum. So, this process is what we call it as refining of petroleum. The crude oil that is separated into various useful fractions by subjecting to fractional distillation, and finally it is converted to desired specific products. So, this refining process includes how many steps? 3 different steps. So, during the refining of crude oil or petroleum, we will have, or we will come across with 3 different steps. So, let us go with one by one. So, first one, it is step 1, it is separation of water. As I told you, it is present very deep in the earth's core, and it is present after brine solution. So, during its extraction, how it can be extracted means extraction of crude oil, it is done in this way. That means 2 coaxial pipelines are to be inserted into the oil bearing region. So, say this one it is earth's core. So, in this layer we are having crude oil. Crude oil is present in this layer, say for example. So, into this oil bearing region we have to insert 2 coaxial pipelines. That means both the pipelines will have the same axis. Okay. So, in the outer side pipeline, if I am going to apply pressure, that means in the outer side one, I am going to apply pressure like this. So, it is able to give us crude oil that is present in this layer. It is extracted from this inner side pipeline. So, this is what we call as extraction process. So, during this process, as I told you, last layer it is of brine solution or NaCl. So, sometimes, it is mixed with that salt water. Oil, it is mixed with salt water. So, it needs separation. During refining, what is the first step? Separation of water, or we will call it as Quaternions process. So, what is the specific name that is given to this process or phenomena? Quaternions process. So, what will happen in this one? Crude oil from the oil well, that is oil bearing region, is an extremely stable emulsion of oil and water. So, what do you mean by emulsion? So, emulsion is nothing but a kind of colloidal system. So, what do you mean by colloidal system? So, colloidal system will contain 2 different components. Colloidal system will have 2 components. One is dispersed phase, and the other one it is medium, dispersed medium. So that colloidal system will contain two different components, one is dispersed phase and the other one is dispersed medium. So in this case, if what is emulsion, it is an example for colloidal system I told you. So in which phase is an example for liquid as well as medium is also an example for liquid. That means two components of the colloidal system are existing in liquid form. Phase is nothing but liquid form as well as medium is also nothing but liquid form. So that means two immiscible liquids, that is what we call it as emulsion. So what type of liquids we have considered? Oil and water. Oil and water, that is in salt water form. So this emulsion like crude oil, it is extracted from the earth's core and then it is allowed to pass through a highly charged electrodes. If you see that instrument or equipment, so these two are highly charged electrodes, positive and negative electrodes. So into which, into this two highly charged electrodes, we are allowed to pass this emulsion. Emulsion is nothing but crude oil that was extracted, which is having oil and salt water. It is allowed to pass through this highly charged electrodes. Then what will happen? Because of density variation, this water droplets were expressed in blue color. So they will coalesce. Wherever that water droplets are present on the surface of oil, they coalesce, that means they combine. Initially they are like random dispersions in the oil. That is what we call it as colloidal system. They were present like random dispersions. So they combine to form a bulk form, that is large droplets, and they get separated like two different layers, water layer and oil layer. So and then using that separating furnace and all, these two layers can be separated because of density variation, they get separated. So this is step 1. So after extraction of crude oil, it is then subjected to refining. The refining means nothing but purification. So it will include how many steps? 3 different steps. Step 1, it is separation of water, and this process is also known as Cottrell's process. And coming to this Cottrell's process, so that crude oil extracted, it is in the form of emulsion. Emulsion is nothing but a colloidal system which will contain two components, dispersed phase and medium. So in this case, two are liquids, that is oil and salt water. So for removing that salt water content from the crude oil, it is allowed to pass between two highly charged electrodes. So as a result, because of density variation, water droplets, they combine, or we will call it as coalesce, to form bulk or large form of water droplets. So that the two different layers we can expect, so that they can be easily separated with the help of separating funnel. So this is what is happening in the case of step 1. So what is step 2? Step 2, it is meant for removing harmful sulfur content, if any, it is present in the crude oil sample after extraction. Step 1, in which salt water, that is brine solution, if any is there, that we removed. And then it is subjected to removal of sulfur. So during that average chemical composition of petroleum we were discussing, I told you about this content of sulfur. So it is very harmful or toxic in nature. If it is not removed up to permissible limits in the crude oil sample, so whenever that were put in application form, that means for transportation purpose and all as a fuel, then it is able to cause cancer, that is carcinogenic in nature. So it needs removal up to its permissible limit value. So this will play a major role. So step 2, it is removal of harmful sulfur compounds. If any sulfur content, if it is present in the extracted crude oil sample, so it can be removed by adding copper oxide to the crude oil. So if sulfur, if it is present, then definitely it will combine with this copper oxide, thereby producing a precipitate of copper sulfide. So this copper sulfide, it is insoluble solid, that is precipitate form, it is produced. So it can be simply removed by filtration technique. So now that crude oil sample, it is free from sulfur compounds also. Step 1, it is meant for removing brine solution or salt water from the crude oil, and step 2 includes removal of harmful sulfur compounds, and then it is finally subjected to step 3, that is fractional distillation. So this fractional distillation is nothing but the final step. So after this fractional distillation, it is done for the crude oil sample, we will get several fractions like petrol, diesel, naphtha, kerosene, like that several fractions we will get. Okay, so let us see one by one. So in this fractional distillation, what we have to do is, initially that crude oil or petroleum, it is heated about 400 degrees centigrade using an iron retort. So in an furnace, which is a closed one, that is what we call it as iron retort, with the help of a pipeline. So into that iron retort, one pipeline it is fixed, and into which crude oil it is allowed to pass, and then it is subjected to heating by maintaining a temperature of 400 degrees centigrade. Okay. So after this heating process it is completed, what will happen? This petroleum will convert into vapors. Vapors of petroleum are then allowed to pass into a tall fractionating column, that is called cylindrical container. So that is tall fractionating column. It is very tall in its height. It is provided, or it will have a trace, number of trays at different heights, they were fixed, and each tray it is having one chimney and one downspout. So this chimney and downspout are able to make the vapors to move up and down. So vapors will move in upward direction and then downward direction basing on the requirement. So for that chimneys and downspouts were provided to the trays. So this will allow the vapors to go up and down, and finally different fractions are collected in the trays. So all these volatile constituents are evaporated first, that is by heating them up to a temperature of 400 degrees centigrade using one iron retort or furnace, closed one. So and then allowed to pass to a tall fractionating column. So let us see how this will happen. See, this is the figure that is representing a tall fractionating column. So this is what we call it as iron retort. As I told you, this is iron retort, or we will call it as furnace, which is maintained at 400 degrees centigrade temperature. If you notice, it is provided with one pipeline, this one. So inside the pipeline, we need to allow the passage of crude oil, which is free from salt water, that is step 1. So allowed to pass through that crude oil, it is allowed to pass through this pipeline. So and which is heated at 400 degrees centigrade. So after that evaporation will take place. So those vapors are allowed to pass into this tall fractionating column. As I told you, it is having, or it is provided with trays, steel trays. Each steel tray it is provided with chimney, and then this is what we call it as downspout. So as they are vapors, they try to move in upward direction. All these arrow marks indicate it is moving in upward direction. So now what will happen by passing that vapors into this tall fractionating column? They involve in condensation. Condensation means change of state from vapor to liquid. So we subjected to 400 degrees centigrade. First heavy oil we will get. If it is involving in cooling process, around 380 degrees attainment of temperature, heavy oil gets separated as a fraction first, and then lubricating oil. After reaching its boiling range, each fraction gets separated out. So after heavy oil, lubricating oil will be separated, diesel oil, kerosene, naphtha, gasoline, and finally petroleum ether. Uncondensed gases, that means less than 30 degrees centigrade of temperature. At the top we are having one provision, that is outlet for collecting uncondensed gases. So this is what is happening during fractional distillation. After each fraction it is separated out, using one separate outlet they will be collected. So what kind of fractions are able to produce? Let us see. So all these vapors go up and they become gradually cooler, and fractional condensation takes place at the different heights of column. So higher boiling fraction condenses first, while the lower boiling fractions turn by turn. So let us go with the fractions that are going to produce first. As I told you, first thing it is residual content, that means above 400 degrees centigrade if anything is present as a component in the crude oil, as we are heating up to 400 degrees centigrade. So it will be present in that content as residual matter, that is what we call it as asphalt or petroleum coke. And its boiling range it is above 400 degrees centigrade, and carbon composition it is above C30. So and it is having an applications as I told you, for road making it is very much useful, and also as waterproofing agent. And what is the first fraction that is separating out? Heavy oil when subjected to refractionation. If it is subjected to refractionation again, it is able to release lubricating oil, which is having an application of lubricant. It can be used as a lubricant for reducing friction. And then petroleum jelly, that is having a commercial name, that is Vaseline. So it is used in cosmetics and medicines, it is having applications. And then grease, grease is also having an application, that is it can be used as a lubricant for reducing the frictional force. And the last one, it is paraffinic wax, we know very well, in candles and boot polishes it is having applications. So first thing, it is heavy oil, it is obtained during the fractional distillation. So and this heavy oil will have carbon composition of C17 to C30 and its temperature range, it is 320 to 400 degrees centigrade. So just now we discussed, if a heavy oil it is obtained as a first fraction, if it is subjected to fractional distillation, so many things we are getting which are having applications. And the next fraction, it is diesel oil, 250 to 300 degrees centigrade temperature, and it is having a carbon composition of C10 to C18, and it is having an applications like fuel. It can be used as a diesel based engine fuel. So next one, it is kerosene. Boiling range, it is 180 to 250 degrees centigrade, and the carbon composition, it is C10 to C16. It can be used as an illuminant and also as a jet engine fuel. So and next fraction, it is naphtha. It can be used as a dry cleaning agent or as a solvent in dry cleaning, and its boiling range, it is 120 to 180 degrees centigrade, and its carbon composition, it is C9 to C10. Next one, it is petrol. If it is artificially prepared, we will call it as gasoline also, and its boiling range, it is 40 to 120 degrees centigrade, and the carbon composition will be C5 to C9. We know very well it can be used as a fuel and also as a solvent in dry cleaning. And the next one, it is petroleum ether. It is a very good solvent in organic laboratories, chemistry laboratories, and its boiling range, it is very less, 30 to 70 degrees centigrade, and coming to carbon composition, it is from C5 to C7. And the last one, that is uncondensed gases. So their boiling range, it is less than 30 degrees centigrade, almost it is equal to room temperature, and its carbon composition, it is from C1 to C4. So it can be used as a domestic fuel under the name, that is LPG, liquefied petroleum gas. So these are the various fractions that are produced after reaching their boiling range when petroleum or crude oil, it is subjected to fractional distillation. So finally, we came to end of the session. What we have discussed so far is liquid fuels. In that, we have considered an example, that is naturally existing liquid fuel, that is crude oil, its introduction, and then its classification, how many types of crude oils were produced due to fossilized matter in the earth's core. After classification, we went for extraction of crude oil, how it can be extracted, that is using two coaxial pipelines. They were inserted in the oil bearing region, and then extraction it is done. And after that, most important thing is refining, how it is subjected to refining process. So it will include 3 different steps. Step 1, it is meant for removing water content. Step 2, it is meant for removing sulfur, harmful sulfur if any. And step 3, it is fractional distillation of crude oil. So in the coming session or in the next session, we are going to discuss about preparation of synthetic petrol or gasoline. So that's all for today's class. Thank you very much.